Okay, I'm going to go over the midterm review part with the graphing, and remember this is without a calculator, so make sure that you are not using one. So first of all, when we graph an absolute value graphs are a V shape. We have to first figure out what our vertex is, and we go opposite, same. So the opposite of -1 is +1, and then the same exact value, which is 2. So that's the vertex. Up or down, we look at the number in front of the absolute value. If it's positive, it's up. If it's negative, it's down. This one's positive, so it'll be up. All right, so let's go ahead and start off with the graph, starting with +1, 2. And then what we're going to do is we're going to use the slope. This is a slope right here in the front. It's rise over run. So that's rise 1, run 2. You could rise 1, run 2 again. You want to go in the back direction, rise 1, run 2 to the left, rise 1, run 2 to the left. And then this is your graph. Okay, we're going to do the same thing to this next problem right here. Again, we want to do opposite, same. So opposite of +2 is -2, same number, -1. Since this is a negative in front of the absolute value, this is going to go downwards. Right? So let's go ahead and plot this first vertex point, which is -2, -1. And from there, we're going to use this as a slope. You could put that over 1 if it helps. It's going to go down 2 over 1. Down 2 over 1, down 2 over 1. Remember, it's a V, so it's going to be the same thing on the left side. Down 2 over to the left 1, down 2 over to the left 1. And that is the graph for that absolute value. So remember, absolute value is a V. These ones down here are also absolute value problems, but they're not given the actual equation. You have to come up with it. So remember that the equation for absolute value is y equals a times the absolute value of x minus h plus k. The a value is your slope. So that's a rise over run. And then the vertex are from these two right here. And remember, you go opposite, same. All right, so let's go ahead and write the equation. We have y equals, I'm going to go ahead and put in the absolute value here, and we're going to plug in the vertex. So this vertex point is -1, -3. So you want to go opposite of x, so opposite of -1, +1, same sign, -3. And then let's figure out the slope. So to figure out the slope, we go from one point, follow it up. Oh, there's the other cross-section point. It's rise 1, run 1. 1 over 1 is 1. So you could write 1 in the front here, but 1 times anything is itself, so you really don't need that. So that's that first part. All right, the second part is asking for the domain in set notation. So set notation is where we write the x such that, and the domain keeps going to the left and to the right. So you can write x as an element of all real numbers, or you can write -infinity less than x less than +infinity. So this way, or x such that x is an element of all real numbers is another way to write it. And this is an r right here. All right, the range. The range is your y values. So what's happening with the y? Well, it goes on and on forever upwards. So that means y is greater than when it goes up. It is also equal to, because it's a solid dot here, and remember we're talking about the range, which is the y. The y is -3. You start at -3 for the y before the graph goes up and up forever. All right, let's do the same thing on this next one right here. So using our equation, we want to figure out what our vertex point is, so we can plug it into this equation. So vertex point, we're going to have right here, which is +2, +2. So we go opposite inside, which would be -2, and then same sign, +2. And then we have a slope. This one actually goes down. So it's down 1 over 1, 2, 3. So down 1 is -1 over 3, +3. So that's what we're going to put in front here, -1 over 3. All right, the domain still goes to the left and to the right, so you have two options. You can go x such that we have -infinity less than x less than +infinity. Or if you want to write it, you can write x such that x is an element of all real numbers. Okay, the range. looks like the arrows are pointing down. So pointing down means we have y is less than or equal to what y value? 2. All right, let's go ahead and take a look at this next one. We are going to find the solutions. It's actually already graphed for us here. So we're just looking at where does this V shape right here, and where does it cross with the line that's already drawn in here. And the values that we're solving for are x. If you write this equation, we want to figure out what is x equal to. Well, let's figure it out. This is a point of intersection right here, and this one is 1 as well. So follow it down, find the x value that they cross at. So it looks like we have x as -3 and 4. I'm sorry, -1. So this is -3 right here, and this is -1. All right, x equals -1. Okay, so we have the 2 answers. All right, let's go ahead and graph exponentials. So again, you're not going to have a graphing calculator for this, so you're going to have to do this by hand. All of the x values are always going to be -2 to 2. Our y-intercept is 0, a, and a is 2. All right, let's plug it in. I'll do the work down below here. So we're just going to plug in these values into that equation. So the first one we're going to plug in is the -2. So we have 2 times 1/2 raised to the -2 power. All right, simplify exponents first, so leave the 2. And then remember, a negative exponent flips this. So this becomes not 1/2, but 2/1, or just 2. And 2 squared is 4, which gets 8. All right, let's plug in the next number. So we have 2 times 1/2. This time we're going to plug in the -1 in the exponent. All right, do the exponents first, so leave the 2 in the front. And then 1/2 to the -1 power. Well, remember, a negative exponent flips this, so flipping it becomes a 2. And 2 to the first is 2. 2 times 2 is 4. All right, let's go ahead and plug in the next one. So we have 2 times 1/2, and this time it's to the first power. Well, that first power is just 1/2, so 2 times 1/2, or you could think of it as half of 2, is 1. And then the last one we're going to plug in is the square. And if you square the 1/2, it's like 1/2 times 1/2. Always do exponents first. 1 times 1 is on top, and 2 times 2 is on the bottom. Keep in mind you can make this 2 into a fraction by going over 1. Multiply across the top, across the bottom, and reduce. All right, so we have all of our values. Now all we have to do is plot those. So I'm going to go ahead and start plotting these. We go -2, +8, it's off my graph, -1, +4, 0, 2, 1, 1, and then 2.5. So we are going to make sure we don't touch this x-axis because that is where the asymptote is. The graph gets closer and closer to this line. And by the way, the equation of that line is y equals 0. So when you graph it, draw it. Don't stop here and draw an arrow because that looks like it'll go down. So show me that you know it stays above the x-axis by continuing it on to the right. All right, let's do this next one here. So again, we have -2 to 2. And we're going to figure out what our y-intercept is. It's 0, a. That's -3. All right, let's go ahead and plug in some of these values here. So we're going to be plugging in the -2 first. So start with -3 times 2, and we're going to plug in the -2 power. Remember, do exponents first, so leave -3. Remember, you're flipping this. 2 squared is 4, and flipping that makes it 1/4. So when you multiply fractions, make sure you put this -3/1, multiply across the top, which is -3, multiply across the bottom, which is 4. So -3/4. All right, let's plug in the next one. So we have -3 times 2 to the -1. Do exponents first, so you have -3. And then flipping the 2 makes 1/2. You can make this -3/1. Multiply across the top, -3. Across the bottom is 2. So that's -3/2. Or you can write it as -1.5. or 1.5. Same thing. All right, the next one we're going to plug in is the 1. So I'll do that work here. So we have negative 3 times 2 to the first power. And that's just negative 3 times 2, which is negative 6. And the last one is to plug in the, negative 3 times 2 to the second power. Exponents first. So it's negative 3 times 4. And negative 3 times 4 is negative 12. All right, let's go ahead and plot these points. So you have negative 2, negative 3/4, negative 1, negative 1.5, 0, negative 3, 1, negative 6, and the other one's off my graph. So remember that you're not touching this x-axis. The equation of this asymptote is y equals 0. When you graph it, make sure you stay below the asymptote. And make sure you run all the way across so I could see that you know it keeps going, not an arrow way up here. All right, let's go to the back side. Here we have quadratics. Quadratics give you parabolas, which are U-shaped. Here we have, notice the parenthesis, it's similar to the absolute value where you go opposite, same. And the opposite of positive 2 is negative 2, same number, negative 3. All right, let's go ahead and take a look at our table. If you don't remember, we had 1, 1, 2, 4. We multiply the y values by a. A is the number in front of the parenthesis. There's no number there, so we don't need to multiply it. We're going to use these points. So start at negative 2, negative 3, and from this point, we're going to go over 1, up 1, over to the right 2, and then up 4. And then remember that it's symmetric, so on the other side, we'll go left 1, up 1, because we're making a U shape, left 2, and then up 4. And this gets you your parabola. All right, the axis of symmetry is a line that splits right down the middle here. And if you look at the line that splits this right down the middle, which is right where the vertex is, oops. Let's see if we can get this light to turn on. There we go. That is an x equals, and it's always x equals. X equals negative 2. You can get it from the graph here or right from the vertex. Okay, which way does this open? The arrows are pointing up, and that's because their number in front of this parenthesis is really a positive 1. All right, the domain. This graph goes to the left and right, but this is asking you to write it in interval notation. So that's just from negative infinity to positive infinity. Range, it start from the bottom, and it goes at negative 3, the y value, right? Range is y, negative 3. Negative 3 and goes on and on forever. Oops. Negative 3 and goes on and on forever is infinity. And yes, you want brackets on here because there's a dot on the negative 3. All right, the next one right here is not as easy to find the vertex because you can't just go opposite same. This is in standard form. So to do that, we're going to have to use a formula. The formula is x equals negative b over 2a. And let's do the ABC chart here so we can figure out what are our values for a, b, and c. A is negative 2, B is 12, and C is negative 17. Let's plug it in here. Opposite of 12 is negative 12 over 2 times A, which is negative 2. Negative 12 divided by 2 times negative 2 is negative 4. And negative divided by negative is positive. 12 divided by 4 is 3. So the x value of the vertex is 3, but we still need to find the y. So we're going to plug this 3 back into this equation. So you have y equals negative 2 times 3 squared plus 12 times 3 minus 17. All right, do exponents first. So we have 3 squared, which is 9. Remember, that means 3 times 3. And then we're going to multiply next. So we have negative 2 times 9 is negative 18. 12 times 3 is 36. And then last steps, put this together. So 18 minus 36, or sorry, negative 18 plus 36 is 18. And 18 minus 17 is 1. So this one right here, don't forget, we use that numbers 1, 1, 2, 4. This time we have an a value of negative 2. So we are going to multiply these by negative 2. Always the second number. So this gets you negative 2, this gets you negative 8. So after I graph my vertex, I'll go right 1, down 2, right 2, down 8. So let's go ahead and graph that. So we're going to start with our vertex, which is 3, positive 1. And then we're going to plot these points. So we want to go right 1, down 2, right 2, down 8 is one more past that. Okay, left 1, down 2, left 2, down 8, and again it's past that. You should be drawing U shapes, not V's. All right, the axis symmetry is what goes right down this middle. And notice that goes right through the number 3. X equals 3. You can look at the graph or you can look at right here. X is 3. It's pointing downwards, and that's because the A is negative. The domain, it goes left and right, so that's going to be all real numbers. You go from negative infinity to positive infinity. And then the range, it starts at negative infinity and ends at negative 1. Oh, sorry, not negative 1, positive 1. So it starts at negative infinity, goes up to positive 1. So we go negative infinity, positive 1, and then use a bracket. And the range should match the y value for your vertex. All right, and then the last part of these are finding the zeros, max, minimum, or the values. Zeros are actually where it crosses the x-axis. This is a 0, and this is a 0. So let's go ahead and figure out what those coordinates are. So this coordinate is negative 1, 0, and this coordinate is positive 3, 0. Those are my zeros. Max or minimum, this has the lowest point, so lowest is considered a minimum. And that value is the y value. Max or minimum value is the y. So what's this y value? Let's follow it over here. This is negative 1, 2, 3, negative 4. Okay. It's always the y value for maximum. All right, this next one right here, it's asking you what is the zeros again. There is only one 0. It only touches the x-axis right here. 1, 0. All right, this is also the lowest point, so that's a minimum. And the y value of this, if you go to the right here, that's going to be y value of 0. All right, and then the last one right here, zeros, it actually touches twice here. So we have it at 1, 0 and 3, 0. And this is a highest point. So a highest point is considered a maximum. And that highest value right here for the y is 1. Okay, and that's it.